Hey guys, welcome back to my YouTube channel. This is a continuation video of conditions of binocular vision where we discuss about the fourth condition, that is fusion. So if you haven't watched my previous videos, please go through it so that you can understand this video properly. Okay, so let's get to the contents of the video. So here we'll discuss about retinal correspondence, which includes corresponding points, disparate points. Then we'll discuss about Horopter, and then fusion, which includes retinal rivalry, suppression, amblyopia, etc. So we'll start with corresponding points. What are they? These are 2 points, one in each retina, which on stimulation produce an impression of single object in a localized direction in space. So when you're looking at an object, the 2 visual axes intersect. The images are produced on the retina, specifically on fovea, and the fovea being the best corresponding points, the stimulation produces impression of a single object. There are other pairs of retinal points as well which produce a single image apart from the fovea when the eyes is still fixating the same object. These points are on the corresponding halves of the retina and at equidistance from the fovea. In the given figure, these are the 2 retinal points which are equidistant from fovea and produce single image of the object K. So this inherent relationship between the paired retinal visual cells or points in the 2 eyes, which on stimulation produces an impression of single object, is called retinal correspondence. And with reference to the fixating object, the other pair of points which produce diplopia are disparate points. In the given figure, this is the fixating object. So any object beyond this point or within this point, they produce physiological diplopia. Heteronymous when within the fixated point and homonymous when beyond the point. And the pair of retinal points that produce diplopia are disparate points. So do not understand the physiological diplopia part here. I would request you to go visit the part 2 of this video since I've already discussed physiological diplopia there. So let's understand what's Horopter. Now that we've understood corresponding points, I think understanding Horopter would be easier. So let's recollect what we've learned. First thing that we've learned is that when we fix a point in space, for example, O in the given figure, the corresponding points, that is fovea, get stimulated and we perceive a single object, isn't it? The second thing that we've learned is that there are other numerous corresponding points as well. So what happens is, the direction lines from the pairs of the other corresponding points, they intersect through the nodal point to other points in the space and produce single images. So Horopter is nothing but the locus of all such points in space that produce an impression of single object. This circle is called Muller's horizontal Horopter, and the Horopter changes with every fixating point. So in this slide, we'll see the steps that occur before fusion. First is the fixation of object. Second, the retinal images that are formed. Third, the transmission of these sensations to the occipital lobes. And then the fusion. So how does fusion occur? Sensations reach the brain via visual pathways. So now the brain receives 2 monocular neural images. So to interpret it as a single object, it needs to fuse the 2 percept. If the 2 images are alike, then the fused binocular percept would be same as the monocular component. So that's not difficult if the 2 images are alike. But if the 2 images differ in distinction, like due to anisometropia, aphakia, etc., then mind has to work a bit, and it can accept only one perception at a time. So it will always accept the one with a higher quality. For example, like in our real life, we also do the same thing, isn't it? We are attracted more towards a good quality video than a poor quality one. So similarly, the mind accepts the one that has the higher quality. So when the images are not widely different or of different wavelength, of different color, and the brain cannot fuse it, what does the brain do? For some moment, the 2 images may coexist, but then the retinal rivalry develops. So the brain accepts alternate percept. That means that first few seconds one image and then the other. So this continues as long as we look at that object. So this is retinal rivalry. the competition for perceptual dominance. So when the impressions are unequal in potency, the stronger one will occupy the attention and the weaker one will be suppressed. And now that the other eye is not in use or suppressed, it will lead to amblyopia. An example of this case is non-alternating squint, where the image in one eye is definitely inferior in quality, and then it leads to suppression and ultimately amblyopia. So, amblyopia is a condition of the eye in which the visual efficiency is reduced without obvious defect or change in the eye externally. Thanks for watching this video. I hope you've understood the concepts. Please like, share and subscribe, and also click on the bell icon to receive notifications whenever I put a video. And if you have any suggestions or complaints, do let me know in the comment section below.